Hello. Testing, testing, 1, 2, 3, testing, testing. Well, that was interesting. Sorry about the delay, folks. I had a very strange thing that just happened with respect to the stream. The stream that I had started sort of ended abruptly, and the best I can figure on what happened, this sort of stopped me with some sort of message about me playing supposedly copyrighted music and or video. Apparently that's a thing they're checking for. And I wasn't playing any copyrighted music or video to my awareness. However, my wife was listening to the news in the other room, which was barely audible, but it might have been picked up on the speaker, on the microphone, and might have been relayed through YouTube. And we still have a midterm going on in the background. Midterm? What? I don't know what that means. Yes, yeah. A joke. Ha ha ha. So yeah, that was stupid, like really quite stupid. I hope that it doesn't happen again. But anyway, very, very odd. Anyway, how's everybody doing today? Hopefully you're doing all right. Last time, we were talking about some of the sort of extended topics of the course. Last time we finished off visualization, and we were talking about date formats and how to work with dates. You have a midterm going on for Math 1ZC3. Okay, so is that a take-home midterm then? Presumably it is. That would explain why the numbers are so low. Did somebody really schedule their test over top my lecture? That is... Boy, today is not the day for live streaming. Jeez. Interesting. Well, anyway, well, in that case, this lecture is going to be mostly for the benefit of people watching it in posterity. So, to those of you who are watching this after it has been posted, how dare you? How dare you? How dare you not do your test and watch my live stream instead? Instant fails for everybody who didn't watch this live stream at the time it was being streamed. I'm kidding, of course. Yeah, and I'm right in the middle of that. Thank you for that information, Nishan. I would have wondered why I only had 5 people in the stream otherwise. So anyway, the topic of today's discussion is going to be databases. I guess the burden of participating in the class is going to fall disproportionately on the 5 people who decided to show up. I don't blame you guys. Yeah, I'm probably going to be doing this to other professors next week, so it's fair is fair. Anyway, where was my... I had that open. Doop, doop, doop. Nope. Doop, doop, doop. Oh yeah, I was just about to open this when the stream crashed, because I'm apparently violating copyright law by existing. I mean, probably true. I'm sure somebody somewhere has copyrighted the rights to my face. Anyway, today we're going to be talking about databases. Databases, this is going to be a strange one because the topic does not fall in line with the rest of the material that we've been covering so far in this class. Databases are an extremely useful thing, and many jobs that you might be interested in pursuing with a degree in computer science are going to have some requirements for some degree of facility with databases. So it's not a core topic in the course. It's not in the calendar description for this course or anything like that. But we're going to cover it anyway because it's useful, extremely useful, and we have some time here at the end of the course. This is like the extra topics type area. So, databases. What is a database? A database is a thing where you store information, obviously. In some ways, you can think of them as souped up CSV files. CSV files with a lot more going on. They can be queried. You can extract specific information from them based on conditions. They have a better way of it's easier to manage a database once you know the databasing language, that is, than manual manipulation of a CSV file. In a lot of ways, they're comparable to spreadsheets. A good mental framework for how a database works is to relate everything that I'm talking about to corresponding operations that you might perform inside of a spreadsheet. So, databases are this interesting thing because they're kind of halfway between a spreadsheet and a programming language in the proper sense. So, generally speaking, the difference between a database and a file that stores data is that you have certain assurances about the manner in which that data is accessed and the permanence of that data. So, whereas if you're using data inside of the context of a Python program, all of that is being stored in RAM memory, so random access memory that's impermanent, non-permanent memory. Whereas all data in a database is stored in dedicated files in a server somewhere usually, although you can also have local instances of databases. And they're sort of, again, accessed by specific means. The types of information that you can have in a database are, of course, things such as bank account information, retailing catalogs, personnel records, all kinds of interesting stuff. So we have this, normally when we are talking about databases, we're starting to talk about server-client relationships. So a database might be something that exists out there on an intranet or the internet, and you access it via specific commands that are being sent off through cyberspace to some hypothetical, physical instantiation somewhere in a Google server or something. So the data inside of databases is atomically updated. So that means that when a transaction is atomic, you can think of that in the same way as atoms were once considered to be the smallest indivisible piece of matter. An atomic transaction is a small, indivisible piece of code transaction. Goodbye, Nishat. Good luck on your test. and then there were 4. So, yes. So the type of database that we'll be talking about today is called a relational database, and we will be talking about a querying language that that you use to put data in and get data out of a relational database. Yes, I expect a lot of people will be watching the stream after the midterm. Again, if you are not watching it, you're welcome. See ya. So, So, again, going back to the spreadsheet example, we have some important nomenclature with respect to a database and what we call the things inside of a database. So if you think about a spreadsheet, such as you would use in Microsoft Excel, you have a number of individual sheets. Those are the tabs along the bottom that you can access and say, okay, I have several different spreadsheets going on at one time here. In relational databases, these are called tables. Then, once you have a table or a sheet in Excel or something like that, you've got rows and you've got columns. So the rows, those would be records in relational databases. And the columns are fields, although the it's not quite pardon me, it's not quite like that, but you know. So records are rows, fields are columns, tables are sheets, if you're again relating this to what you know about spreadsheets. So let's motivate all of this with a good example. Let's imagine that we are running a video rental store, and let's construct the scenario in the following manner. You, as a young entrepreneur, have taken over the management of a video rental store. Let's imagine that it's the 1990s, so this is actually a viable business prospect. And let's say you're inheriting the business from your uncle, and your uncle just knew in his head all of the movies that he had to rent and whether or not they were rented and who they were rented to, because he has a magnificent brain. But let's say that you, being the crass young upstart that you are, you wish to create a more rigid, you want to create a data structure that encapsulates that information, because you don't actually want to run the video store. You want to own the video store and hire people to run the video store while you make all the money. So, with respect to that, you have your database requirements are as such. The things that you need to track are all of the movies that are available to rent, the customers. We need a database of customers that can rent movies, and we need to know which movies have been rented by which customers, preferably when, so that we can calculate if the movies are overdue or not. So, with respect to this, we will be making a relational database that contains 3 tables: a table of movies, a table of customers, and a table of rentals. So here's an example of a small table of movies as we would have it. This is more or less how you would express it in a CSV file or in a spreadsheet or something like that. So we've got a number of movies here. We've got Casablanca, Back to the Future, Monsters Incorporated, Field Dreams, Life of Brian, and 12 Angry Men. All of those being good movies. So obviously we are We are a video rental store that only has good movies. So, what we need now is a manner to organize this table. Within the context of relational databases, we call this a schema. Schema is, you can kind of think of it as, if you were thinking of each record inside of a relational database as being a class, you could think of the schema as the parameters that you would give to the init function, or the init method. So these are the things that a record has. These are, or maybe not the parameters to the init method, but the pieces of data that are instantiated by the init method. That's a better way to say it. So, with respect to the above, we have a number of fields, and we have a number of different types of data that can be contained in those fields. So this is an important slide because this tells you what we call the various types of literals, essentially, inside of a relational database context. So integers, instead of saying int, we say integer, the full word. Notice all of these are fully capitalized. That is a feature of the language that we're going to be discussing to use all of these. So we've got integers, we've got real numbers instead of floats. They are 8-byte floats, so they are still conforming to our IEEE standard on floating point numbers, but we call them reals for real number. We have text, which is a Unicode string. We have booleans. Booleans are stored as zeros and ones rather than trues and falses. And we have date. So, with respect to this example table of a list of movies that we might have in a video rental store, we have, as our schema, 4 fields. Four fields. We have the movie ID, we have the title, we have the genre, and we have the rating. The movie ID is an integer, and the rest of them are all text. Hypothetically, you could do some sort of thing where the rating corresponds to an integer value, but normally when we're talking about databases, we're not talking about optimizations on that level. So let's talk about the language that we're going to use in order to actually implement all of these things that we're talking about. Because so far we've been talking mostly academically and talking about some nomenclature and stuff like that. So we actually won't be using SQL. We'll be using a variant of SQL called SQLite. So SQL, some people call it Squirrel, some people call it SQL, stands for Structured Query Language. It is a very widely used database query language. If you ever browse through, job applications or job descriptions, you'll find that SQL pops up quite a lot for certain types of positions, especially anything to do with the internet. It originated in the 70s, and it can be used to perform a large number of interactions. It can fetch records, add data, modify data, delete data, anything you need to do with the data you can do with SQL. The syntax for it is mostly independent of vendor, so you don't have to worry. If you know SQL, you know SQL for pretty much every situation that it's going to be used in. So SQL also supports transactions in the sort of repository sense. Things like committing and rolling back, these sorts of things. It has methods for authorization and stored functions. It's actually a very general purpose language. and it, you can do very complex things with it. However, we are going to be dealing primarily with the basic stuff, because this is like a crash course intro to databases, and we're not going to be, we're not going to get into the advanced stuff, though the advanced stuff exists, because this is not a course on databases. Incidentally, all this cloud storage stuff is a different thing than relational databases. So a lot of this will not be applicable to like cloud storage of stuff. Anyway, so there are a large number of different vendors that offer manners and like basically IDEs for databases. You've got a number of popular commercial packages like Oracle and Microsoft SQL Server. Microsoft Access also uses SQL. You also have a bunch of open source options like MySQL, PostgreSQL, MongoDB, all kinds of interesting ones. And most of these are using SQL to interact with a remote database, although there are some minor variations on that. We're going to be using a variant of SQL called SQLite in this course. SQLite is it's a widely used serverless relational database. So essentially what you're doing is you're interacting with files in your file system as if you were interacting with a server. So you're interacting with it in the same manner as you would the server. However, it is a local file. It is a local file on your local system rather than something remote. So it doesn't. This means that you can run it more efficiently, and for single individual use. Obviously, if you need multiple users and if it's a large database, you're going to want a dedicated server. But SQLite is a fantastic way to introduce the concepts of databasing and teach it to you in a way that is applicable to these larger databasing structures that you may have to use in the future. So, I'm going to pause the slides right here, and I'm going to show you how you can obtain an installation of SQLite for yourselves, so that you can use it on your own computer and follow along with the lecture, etc. So, if you take the internet, you will find that there is a thing on the internet called Google. If you Google SQLite, the first hit that you will receive is SQLite homepage. Going to that link, you will see that it is, and I hope this is not the image that crashed the stream before. I don't think it is, but there you go. SQLite, there we go. This is their homepage. If you go to their download page, this is what it looks like. Now, you'll want to get a version of SQLite that is specific to the particular operating system that you're running. So if you're running Linux, you probably already have it. You can check, you can run it from the command line. However, if you're on Windows, you'll probably want to download this one right here, which is SQLite Tools Win32x86. And this is basically, if you go for one of these guys, all you're going to get is a zip file that contains a DLL, and that's not exceptionally useful if you, if you want to actually like run it inside some sort of environment. But there you go, SQLite Tools. Once you have downloaded and extracted that, boop, 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 you will be faced with something that looks like the following. You'll have SQLdiff, SQLite 3, SQLite Analyzer. The one that you want is SQLite 3. I'm just going to close that. Once you execute it, you will be faced with a command prompt, which is fun. So it says it's connected to a transient in-memory database. Use open file name to reopen on a persistent database. So what it's saying to you right now is, okay, I'm going to let you do stuff, but just keep in mind you don't actually have a file open right now. So in order to open a file, you go point open, and then you enter the file name. In our case, we'll call it moviestore.db. And you can see inside of the directory, it creates moviestore.db. And it currently contains nothing. So, incidentally, in SQLite, all of the sort of commands to the command prompt, the things like your save and quit and things like that, must be prefaced with a period. There we go. So, this is cool. This is fun. Everybody having fun so far? Those 4 people who are in chat right now, are you guys having fun, or are you all bots? It's entirely possible that you're all bots. Well, actually, no, because Panka9029 did say good day. Although that might also be a bot. You don't know. If you're not a bot, say I'm not a bot in chat. Yes. So, now that we know how to get SQLite, let's actually do something with it. Again, .quit gets you exited, and if you want help, it's .help, and there is all kinds of commands for you. However, we are going to be doing some SQL stuff. So here we go. The first thing that you have to do in order to initialize a database is you have to actually create the table that you'll be using for the database. You have to have at least one table in order to do anything with it, and as you saw from the file size, when you create a database, it contains no data. So in order to initialize the table, we're going to need to remember what our schema was. So this is the syntax. Create table, movies, then in braces, comma delimited, movie ID, integer, title, text, genre, text, rating, text, semicolon. All SQL commands are terminated with a semicolon. So, also, the words that are capitalized here are case sensitive. Everything is case sensitive in SQL. So, and I'm not going to enter this in because the next slide has some modifications that we can make. So, there are a couple of things that you might want to specify with respect to the records in a table. Or, sorry, the fields in a table. Number 1, you may wish to specify a primary key. The primary key is a field that contains a unique identifier for each record. In the case of the example that we're talking about here, that would be movie ID. You can see that's a unique number for each entry. You can imagine that, a movie store might have several copies of Star Wars, so the title wouldn't be unique in the case of all of the movies held by the video store. However, they are separate discs, so it makes sense to have several movie IDs with the same movie. The other thing that we can have here is the distinction between required and unrequired fields. Sometimes you may have a movie that has not been rated, or lacks some information that's in the schema, this is generally speaking okay. The default position of a relational database is that no field is required unless it's specified to be required. So if you do not wish anyone to be able to construct a record that does not have some data that's in the schema, you make those data required. You make those fields required. So within the context of our example, we're going to make the movie ID the primary key, and we're going to make the title required. And you notice the way that we actually specify this is that we put the primary key designation after the integer, after the typing information for the field, and we put the required tag after the typing information for that field. So let's see what this looks like. I guess the chat is all bots, isn't it? Good Lord. So we want to create a table, movies. We want the first field to be movie ID. It is of type integer and it is the primary key. We have a title, which is text and required. We have a genre, which is text, and we have a rating, which is text. Neither of those are being required. There we go. We have created a table. And if we take a look at our database, it now contains 8 kilobytes worth of data. Fantastic. So, with respect to this, let's now learn how to actually put entries into our database. It's very simple. The way that you do it is you use the insert keyword, insert into, and then you specify the name of the table that we insert into the table that we want to actually insert the data into. So, interestingly, we have to specify all of the field names that we are adding to the record. So this is because you don't have to enter them in the order that you don't have to enter the data in the order that they appear in the record. You can mix and match the order, and some elements might be missing, and they might not just be missing from the end. You might have something missing in the middle, so it's necessary to say what goes with what. So let's perform these operations with our neat little movies database. Insert into movies, movie ID, title, genre, and rating, values, 101, Casablanca, drama, romance. One might say that those are kind of the same thing. And parental guidance is advised. Oh, and you need a semicolon. There you go. Now, let's into the movies database. We shall do the same thing, but we shall name it Back to the Future, which is a comedy adventure, also PG. Oh. Yes. So there's an interesting thing for you. And I apologize, I don't think I can actually increase the size of this with respect to how big the text is. So I guess you're just going to have to blow the video up full screen. Can we have multiple required fields? Yes, absolutely. You can make as many of the fields required as you like. In this particular example, however, we only have the one of them. Oh my goodness. So, insert into. Where did I put back? There it is. There we go. So, there we go. So yeah, that's how you put stuff into a database. Just to, just to flesh out the example a little bit, and just to demonstrate the non-requiredness of things that are not required, we can also insert into movies. Let's say we leave out the rating and insert item number 5793. Am I using the correct? Those are angle braces, not round braces. Oh my goodness. There we go. Very difficult to tell the difference between angle braces and round braces in this particular instance. Life of Brian. I'm using the wrong type of quotes. Jeez. Ugh. And this is a comedy. And it is not rated. So there you go. Notice that it isn't barking on us. However, if we tried to enter something which does not have a title, which is a required field, just a ID and a genre, like say 104, and it is fantasy drama. Then it, worked? It shouldn't. Interesting. Well, at any rate, we'll see if it's actually in there when we take a look at getting data out of the table. So, when we want to get data out of the table, we have to specify 4 things. First of all, which fields we want to return, which table we want to return them from, which rows we want to select, and in what order we want to sort them. So, let's take a look. If we type select star, which is the wildcard from movies, then we see everything that's in there. Aha! So, with respect to item number 104 that we entered, but we did not specify a title for, notice that it's being left blank. But that's, I suppose, similar to how this is being left blank. Okay. Well, at any rate. So, if you want to have specific entries, you comma delimit them, and that will give you back just the names of the things and their ratings. If we want to have everything from a particular table with a particular constraint, we would use where genre equals comedy. So that gives us only those entries which have a genre equal to a certain value. However, we also have instead of just strict equality, we also have a like, which returns for us the same gosh darn thing. Oh, wait, I need to add some symbols here, and there we go. So that when you put the % signs in there, you're searching for all of the things that contain the term comedy. So we're getting back not only Life of Brian, which is a comedy, but we're getting back to the future, which is comedy adventure. Notice that we're using the bar symbol here to delimit between the entries. So, and finally, select all from movies, order by title, ASC, according to ASCII. So, this will put everything in alphabetical order. There you go. So, as we just demonstrated, the place that you specify which fields you want to return is immediately after select. The place that you specify the table is from, immediately after from. The place that you select which rows you want to display is you use the where keyword and you specify some sort of conditional statement. Can I see what the bottom of that says? Use like and % for wildcard matching on strings. So there you go. Wildcard matching, very, very useful. Again, this is a more complicated example where rating equals PG or rating equals G and genre is like comedy or contains comedy. So this would return to us all of the comedy movies that were rated PG or G for a fun night with the kids. And then if you want to order, that's not ASCII, that's ascending. If you want to order the data, then you select which field you want to order it by. In this case, we're choosing title, and then you can choose ascending or descending order. If you do not specify ascending or descending order, it seems to assume ascending order. So, this is good. So, now let's take a look at this and bring it back into Python somewhat. Python has, of course, since Python has a library for everything, Python has a library module through which an SQLite 3 database can be accessed. You need to specify the file name of the database stored on the computer, obviously, and you need to open it and use it and close it in a very similar fashion to how you might use a file handle to access something like a CSV file. So, rather than using the open keyword, as you might be used to with respect to other file writing and reading and writing operations in Python, you'll be using SQLite3.connect to videostore.db, and then you do your operations, and always don't forget to close your file handles, people. Don't forget to close your file handles. So Python automatically converts SQL data types into Python, and some Python data types into SQL. So null types become none in Python, integer becomes int, real becomes float, text becomes string, and here's the kicker, date is interpreted as a string in Python. So if you want to extract a date-time object, as we discussed in the previous set of slides, what you're going to have to do is you're going to have to perform manual date string parsing using the strp date, or date p str, one of those methods that we discussed in the previous set of slides. So, in order to make SQL statements from inside Python, you're going to have to format them as strings. So there's a .execute method which will accept a string that contains SQL code, which is kind of weird, right? Kind of strange. It would be strange. It's slightly strange to have this, using one language from within another type thing. But, then again, the object of this is to use Python to interact with a database in the same way as SQL, as an SQL query. So to some extent, it makes sense. So you can see that an SQLite command, such as select star from movies, show me all of that, is you execute that command, and then you, from that command, have to use either the fetch one or the fetch all statements to get the data out of the current or the database object that is created. So, and you have to create it as a cursor using db.cursor. So, that's just about all the time that we have for today for database stuff. Next time when we meet, we'll actually try out this using SQLite 3 in Python, which, we'll do it in Jupyter, etc. But until such time, thank you very much for your time and attention. I hope the test was okay. If you have any questions, please send me an email. And I'll try not to put any more copyrighted music over the stream and cause the stream to crash. See you guys.